Hello, my dear children of class 12 science. Today we do continue again with the chapter that we already started in the last class, that is atom and origin of spectra. So the chapter that we already started is under unit number 8. Okay. Now in today's class, we start with the topic called Bohr's atomic model. Okay, Bohr's atomic model. Now in the last class, that was the introductory class of this chapter, we actually learned about the Rutherford atomic model. Okay, with the most important experiment which was performed by two scientists, Zeiser and Marston, to do the discovery of nucleus and to make a model of an atom, that is called alpha particle scattering experiment. Okay, now when Ernest Rutherford prepared the model, we saw how many drawbacks found in this model. Two drawbacks. Okay, so two drawbacks was made observed in Rutherford atomic model, but this drawback was corrected by another scientist, a great scientist. Okay, and his name is Professor Niels Bohr. So in today's class, we start with Bohr's atomic model. So he prepared the model of an atom just by doing the correction of Rutherford atomic model. So in the year 1900, so I'm writing the year 1913. So look at the year 1913 is after 2 years when the Rutherford atomic model Rutherford made his model, because Rutherford made the model of an atom in the year 1911. So in the year 1913, Professor, so I'm writing the name Professor Niels Bohr. Professor what? Niels Bohr. So he proposed and corrected or removed the difficulties of Rutherford atomic model that was found, okay, in this model by introducing the theory of light, and that is called Planck's quantum theory of light. You know, quantum theory of light, okay, was already proposed by one of the great scientists called Albert Einstein. Okay, the quantum theory of light basically say that the light has what nature? Particle nature. Okay, so this concept of quantum theory, Planck's quantum theory of light, it was introduced in preparing the model of an atom by Professor Niels Bohr only, and that model is called Bohr's atomic model. That's why in the year 1913, as I said, Professor Niels Bohr removed the difficulties of Rutherford model by introducing the application of Planck's quantum theory. Okay, introducing the Planck's quantum theory, which was already proposed by Max Planck in the year 1900. Okay, but the model of an atom prepared by Bohr is actually observed in the form of postulates or in the form of assumption. So there are three postulates of Bohr's atomic model. So now we discuss about the what? Postulates. Okay, now we will discuss about the what? Postulates of Bohr's atomic model. And children, this topic will be asked in the examination. You will be asked to write any of the three postulates, or you may ask to write all the three postulates. Okay, the postulates of Bohr's atomic model. Okay, so there are how many postulates which was prepared by Niels Bohr? Three postulates. So let's discuss the postulate one by one. So let me explain the first postulates in details. Okay, and from this postulate we understand about the model of an atom. The first postulate says that electrons is the only charged particle which revolve around the what? Nucleus. Okay, the electron can revolve only in those orbit. See, look at this postulate. Electrons, which are the negative charge particle, okay, can revolve only in those orbits in which the angular momentum is an integral multiple of h by 2 pi. Now, children, in this relation, if you see, h is actually called a constant called Planck's constant. You know, h we marked by the symbol called what constant? Planck's constant. So the first postulate say that every electron revolve in an orbit. Okay, but those electrons revolve only in those particular orbit in which the angular momentum, that means when the motion is occurred by the electron, definitely there is a momentum of the electron, but when it revolve, when electron revolve in the orbits, then they acquire what momentum? Angular momentum. Okay, because momentum are two types. One is called linear momentum, one is called angular momentum. Okay, so in a rotational motion, or when the body have a when it move in a circular orbit, okay, they acquire what momentum? Angular momentum. But the angular momentum is an integral multiple, the multiple of h by 2 pi. So this means that all the electrons will never move in the particular orbit, and all the electron, whatever number of electrons they move, okay, they will not move in their respective orbits, provided that the angular momentum must be an integral multiple of what? H by 2 pi. So this is the statement, first postulate of what? So first postulate of Bohr's atomic model. But you know, children, that electron which revolve around the nucleus, okay, has mass. There are the mass of electron. Every electron has a mass. So let me just consider that m be the mass of the electron. Let m be the what? Mass of an electron. Okay, that means every electron has a what? Mass. And this electron revolve with a velocity, okay, and that velocity I consider as b. So I write on small b be the what? Be the velocity of an what? Velocity of an electron. And when it revolves around the nucleus in an orbit, okay, then they follow the path like circular path, and every circular path or orbit has a radius, and that radius I consider as small letter r. So small letter r be the what? Radius. So small letter r is the what? Radius of an what? Orbit. So if m is the mass and b is the velocity and r is the radius of the orbit, then we always express the momentum acquired by this electron, and that momentum is nothing but angular momentum. So the angular momentum is actually measured by the relation that is called mbr. So children, look at it, mbr. Actually in the relation, mb means called linear momentum. mb means called what momentum? Linear momentum. Okay, now this linear momentum into radius measure the angular momentum. So linear momentum mb into radius measure the what? Linear momentum. It's an angular momentum. But as for the postulate stated by the Bohr's itself only, we can write the relation mathematically, and the relation is mbr, the angular momentum, is nh by 2 pi. So I am writing this way, nh by what? 2 pi. So look at this relation, a very important relation. mbr equals to nh by 2 pi. So the postulates say that electron can revolve only in those orbits in which their angular momentum, which this angular momentum is integral multiple, the multiple of h by 2 pi. That means every electron acquire momentum h by 2 pi. But if they revolve in the different orbits, then the momentum will be the integral multiple of h by 2 pi, where n outer, and actually indicate outer is the what? The number of orbit in which the electron revolve. And this n is also called a number in quantum optics, and this number is also called principal quantum number. Principal what? Quantum number. So I write on where n is equally start with 1, 2, 3 like that. Now this n also indicate the orbit, number of orbit in which the electron revolve. Like if I put n equals to 1, electron revolve in which orbit? First orbit. If I put n equals to 2, the electrons revolve in the which orbit? Second orbit. If I put n equals to 3, the electron revolve in the which orbit? Third orbit, and it will go on. That means when electron revolve in the different orbit, they acquire their different angular momentum, but the angular momentum is given by the integral multiple of h by 2 pi. Okay, and this particular condition is actually called as Bohr's quantization condition. So this condition is also called what? Bohr's what condition? Quantization condition. Bohr's quantization what? Condition. So from first postulate we get what? Bohr's quantization condition. That's why children, in the examination you may ask to write Bohr's quantization condition, means that is the what postulate that you need to write? First postulate. So Bohr's postulate always give the Bohr's quantization condition. So from this postulate we can even say that we can say that the electron can revolve only in certain discrete orbit. See, electron can revolve only in what? Certain discrete orbit, not in all the orbit like that. Okay, that means if there are 5 electrons are there, they revolve in the first orbit. If there are other 6 electrons are there, they revolve in the what? Other orbit like that. That means the electrons can revolve only in certain discrete orbit of definite radii, not all. This means in these orbits are called stable orbits. That means atom always revolve in a definite or stable orbit, not of the orbit of changing radius. Okay, so this is the first postulate of Bohr's atomic model. Now we go to the next postulate, and that is also called second postulate. The next postulate, the second postulate that was proposed by Niels Bohr is very important, and this postulate actually do the correction of the drawback which was observed in Rutherford atomic model. And you know, one of the first drawback that you saw in Rutherford atomic model was regarding the stability of atom. So Rutherford atomic model say that atoms are not stable, but actually the atoms are stable. So why? Because the second postulate say that while revolving in stable orbits. See, in the first postulate we understood that electrons, okay, revolve in a definite orbits, okay, where the angular momentum is always given by ns by 2 pi, okay, the integral multiple h by 2 pi, okay. That means every electron, okay, revolve in the different orbit acquire the momentum, and the momentum of the electron in different orbit is given by ns by what? 2 pi. That's why that orbits are called stable orbits. But when electron revolve in a stable orbits, the electron do not radiate energy. See, electron when they revolve in a definite orbit of stable orbit, okay, of different radii, okay, that means that electrons they revolve, no doubt, but they do not radiate energy. They cannot eliminate, they cannot eject what? Electron energy, okay, in spite of the acceleration toward the center. That means they are revolving in the definite orbits. Definitely they acquire by the what? For centripetal force, and this centripetal force is actually due to the what? Attraction exerted by the nucleus to the electron. That is called electrostatic force. But even that, the electron will not radiate what? Any energy. That's why the atoms remain stable. When electron does not radiate energy, when they are revolved in a definite orbit, okay, in a stable orbit, that means that atom does not emit energy, and when they does not emit energy, then that atoms are called stable. That's why the atom remains stable and said to exist in what state? Stationary state. So when atom remains stable means this correct the drawback which was observed in Rutherford model, because Rutherford say that the atoms are not stable, but this postulate say that the atoms are stable, because that atom which does not radiate energy when electron revolve in the definite orbit. Okay, so this is the second postulate, okay, which was proposed by Niels Bohr. Okay, now we have the last postulate, important postulate, and that is called third postulate. And third postulate states that when the atom receives energy, see, when atom receives what? Energy from outside, then one or more of its outer electrons leave its what? Orbit, and goes to some higher orbit. And this state of an atom is called excited state. So children, try to understand this particular term, stable state and excited state. Stable means the atom which are not receiving any energy from outside. But when an atom is given some energy from outside, then that atom will be in which state? Excited state. Means when the atom absorbs some energy from outside, then that state of an atom is called excited state. But in this excited state, okay, when atom receive the energy from outside, then the electron definitely revolve in the different orbits, okay, but one or maybe more than one electron from the outer orbits, not the electron which is revolving very close to the nucleus, leave their orbits. Why the electron leave the orbit? Because those electrons which revolve in the outer orbits are not strongly attracted by the nucleus, okay, that's why they can just leave the orbits, and they may go to the higher orbit. They may go to the what? Higher orbit, some higher orbit. So when electron leave any of the orbit and goes to the higher orbit, in that case the atom always remain in what state? Excited state. Okay, that what state? Excited state. But the one important part you need to keep in mind, children, that any of the electron who goes from that any of the orbit to the higher orbit, then that electron cannot remain in the higher orbit. Cannot remain in the what orbit? Higher orbit. That means the electron in the higher orbit stays for a very fraction of second, almost say 10 to the power minus 8 second. Look at the time that is required, that will be taken to remain in the higher of this higher state, that is 10 to minus 8 second. But once they cannot stay in the higher state, then what happens? That electron will return back. So while returning back from higher state to the lower state, any of the lower state, the electron radiates energy. That means, as per Bohr's postulate, he said that atom will radiate energy only when electron or in the form of atom, okay, radiate energy only in the form of electron wave when the electron return from higher state to what state? Lower state. Or when electron jump from higher state to what? Higher orbit to what? Orbit, lower orbit. Okay, so in that case, the atom will be usually called as what state? Excited state. Okay, but means atom radiate energy in the excited state when the electron jump from what? Higher state to what? Higher orbit to what? Orbit, lower orbit. So under this case, we can measure, okay, we can measure the frequency. So remember this part, we can measure the frequency of the emitted radiation, and this frequency is a definite frequency, not a frequency of varying amount. Okay, this is a frequency called definite frequency, and this frequency can be measured in terms of the energy acquired by the electron in each of the orbit. Now children, this postulate can be expressed mathematically also, and we call this postulate in the form of condition, also called Bohr's frequency condition. But for that, let me just follow this diagram. This is the model of an atom proposed by Niels Bohr, okay, where this is the nucleus of an atom, where the positive charge are concentrated at this position, and electron, these are the electron revolve around the orbit, different orbits. Okay, electron revolve in the what orbit? Different orbit. So like you can see, there are 2 electron revolving in the different first orbit. Similarly, there are other number of electron revolving in the second orbit, and it will go on and on. Okay, that means number of electron revolve in the definite orbit. Okay, now this is the case where the electron are, okay, jumping from higher orbits to lower orbit. So if any of the one electron, if they jump from higher orbit to lower orbit, so this is the electron which is jumping from higher to lower orbit, then in that case that electron radiate what? Energy. That electron radiate energy in the form of electromagnetic wave. Means electron radiate energy means the atom is radiating energy in the form of electromagnetic wave. But this radiated energy has a frequency. Okay, that radiated energy has a what? Frequency, and this frequency is measured in terms of the difference in the energy of electron in the 2 orbits, higher orbit and the which orbit? Lower orbit. Means when electron in the higher orbit, that electron has a certain energy, but when the electron jump to the lower orbit, that electron also has an energy, and that difference in the energy of electron in the 2 different orbit where the electron jump, and that difference in energy can be measured in terms of the energy of the emitted radiation. And according to Planck's quantum theory, energy of each photon or radiation is actually equals to h nu. H nu means the frequency. Now let me just consider the energy in the 2 different orbit of an electron. So one is E2 is the energy of electron in the higher orbit, any of the higher orbit, and E1 is the energy of electrons, okay, energy of the electron in any of the lower orbits. But this energy are the energy of electrons when electrons are jumping from any of the higher orbit to any of the lower orbit, then according to Planck's quantum theory, the difference in the energy, that means E2 minus E1, so look at this one, the difference in the energy of that higher orbit and lower orbit is always equals to the energy of the emitted radiation which takes place. And energy of emitted radiation means the energy of emitted photons, and energy of emitted photon is given by h nu, and this nu is actually called frequency. This is what? The frequency of emitted radiation. That means radiation will emit from the atom, or electron will emit radiation only when electrons are from higher orbit to lower orbit, and that energy of the emitted radiation, h nu, okay, in the form of energy of photon, is equals to the difference in the energy between two orbit. One is say A2 and E1. So from here I'll make nu as the subject, so it will be E2 minus E1 by h. So look at the relation that we got from third postulate. The relation is nu, the frequency, this is the frequency of emitted radiation, is equals to the energy difference of two orbit divided by a constant. This constant is called Planck's constant, and this relation measures the frequency of emitted radiation, and this condition is called Bohr's frequency condition. This is called Bohr's frequency condition. So what is the third postulate? Bohr's frequency condition, and from this condition we measure the frequency of emitted radiation, and this frequency is called a definite frequency. Definite what? Frequency. So these are the postulates of Bohr's atomic model, and from this postulate Bohr's prepared the model of an atom. Now in the next YouTube video we discuss in detail about the Bohr's theory of hydrogen and hydrogen-like atom.